Hello everyone, myself Vinay Kumar M. So I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So I was actually teaching the 7th chapter of 8th standard mathematics subject, that is comparing quantities. So in this comparing quantities, I have already done part 1 video. So in that part 1 video, I have explained about ratios, percentage, discounts, tax and exercises 7.1 and 7.2. So in this particular part 2 video, I'll be teaching interests and compound interest. Exercise 7.3 which is there in this particular chapter. So you might have heard about banks which put interest on a particular money. So what do you mean by interest? So interest is that money which is actually added for the initial amount of money for a certain period of time. Like for example, if you give a money or if you take some loan from bank or if you are depositing your money in bank for a certain period of time, then for that time period they will actually put interest for that money and they will pay back that interest, or you should actually pay them the interest if you are taking loan. So for example, if a bank is putting interest of 5% annually, so annually a bank is putting 5% interest. So if the principal amount which you are actually keeping in that bank is 1000 rupees, then after 1 year, this 1000 rupees will be interest plus the amount which is there, like that is 1000 rupees. So total amount after 1 year. So amount after 1 year will be equal to 1000 rupees plus 5% interest on 1000 rupees. So 5% interest on 1000 rupees plus 1000 rupees will be the total amount after 1 year. That means 1000 plus 5% of 1000 is 5 by 100 into 1000. So how to calculate percentages, how to calculate ratios and all, I have explained in my previous video. You can refer that. So that is the part 1 video of comparing quantities. Here 0, 0, 0, 0 gets cancelled. So 5 into 10 will be 50. So for 1000 rupees, 50 rupees will be the interest, and this 50 rupees is added with this 1000. So here interest is 50 rupees. Why? Because 5% is the interest for 1 year. So you have kept that particular 1000 rupees in a bank for 1 year, means after 1 year you will get 50 rupees interest plus your initial amount which you have already kept in the bank. So this is the concept of interest. Let's suppose say if you are keeping the same money for 5 years. So at that time you should remember there will be compounding of interest. So it will not be a simple interest. So this is actually simple interest. This you can actually call it as simple interest because you are actually getting annual interest 5% and exactly you are keeping 1 year that particular amount. So you are just getting interest of that particular amount for 1 year. So what if you are keeping the same amount 1000 rupees for 5 years? At that time whatever interest you will get in the first year will be added to your principal amount, and that new principal amount will be the next year's amount. So again the next year when they put interest, they will actually put interest on interest which has already there, which was already put for the principal amount in the first year itself. So for example, in the first year, so whatever principal amount you had, for that they added interest of 5%. So in second year the interest, like the total amount will be the principal amount plus interest whichever you have got in first year. For this they will actually calculate the interest. So here interest will be calculated on the first year's interest and the principal amount. So I1. So I2 will be the interest for I1 plus P. That means the principal amount plus I1. So in the second year, so in the third year, it will be P plus I1 plus I2, and the I3 will be calculated for the I2, I1 and P. So for the total amount which has got in second year, by the end of second year, for that particular amount, the third interest, like the third year interest will be applied. So this is actually putting interest on interest. So that's why it is actually known as compound interest, or it is known as compounding of simple interest. So initially 1 year's interest was simple interest. So for that interest, it got accumulated. So interest is actually getting accumulated over principal amount every year. So that actually shows the interest is growing, the amount, the total amount is growing. So that is actually the compounding of interest. So this is known as compound interest. I will just write the word compound interest. So now we cannot calculate compound interest for every year by doing long method, because initially if I keep 1000 rupees in bank for 3 years, and if the rate of interest in that particular bank is 5% for annual, like annual interest in that particular bank is 5%, and I'm keeping it for 3 years means, so my principal amount was 1000 rupees. So after first year, my 1000 rupees will have interest of 5%. So 1000 plus interest, that is I1. So what is I1? I1 is actually equal to 1000 into 5%. So 5% is 5 by 100, which is actually 50 rupees. So by the end of first year, I will be getting 1050 rupees. So for second year, this 1050 rupees will become the new principal amount P2. So initially this particular amount was principal amount P1. Now I have got the new principal amount P2 because it has, like, the first year's interest has got added to that particular first principal amount. So second year it will be 1050 plus I2. So here I2, that is interest 2, will be 1050 rupees into 5%. So here it will become 1050 into 5 by 100. So I1 was actually 1000 into 5 by 100, but I2 is actually 1050 into 5 by 100. That actually shows you are putting interest on this 50 rupees and 1000 rupees both. So that is the compound interest, like second year's compound interest. So I2 will be equal to, here 0 0 gets cancelled, 5 ones are 5 twos are. So 2 ones are 2 5s are 10, 2 twos are 4, 0.1 will be remaining 5. So 52.5 rupees will be the second interest, like second year's interest. So your new principal amount will be, that is P3, will be 1050 rupees plus 52.5 rupees. So that will be 1102.5. So this much will be the third year's principal amount. So by the end of third year, if you want to calculate the interest, this is actually the I3. So what is I3? I3 you can calculate this. So 5 ones are 5 twos are 10, 0. So 20 is there. So this will become like 2 tens are 20. Here it is 2 5s are 10, 10 is there. So 2 5s are 10. So again 2 is there, 2 ones are 2. Point is there. So 2 twos are 4, 1 is there. So 10. So 5. So here it will be 551.25 divided by 10. So 551.25 will be 55.125. This will be your new I3. So your total amount after your third year will be, A3 will be equal to P3 plus I3. What is P3? P3 is actually 1102.5 plus what is I3? I3 is 55.125. So when you add this, you will get somewhere around 1157.625. So this will be your third year's interest. So this is how you should actually go on doing. But doing this continuously, now I have given 3 years, so 3 times I have calculated the interest. But if I give 10 years or if I give 20 years, you cannot calculate 10 times or you cannot calculate 20 times the interest. You cannot calculate interest for every year. So you should actually derive a formula. like general formula where if you substitute values in that particular formula, you should be able to get what is the total amount you will be getting after 10 years, or what is the total amount you will be getting after 20 years. Because here it was 3 years, so I calculated 3 times and I got 1157.625 rupees. So that was the amount which we would get at the end of third year. But here, if it is 10 years or 20 years, then you should actually derive a particular formula. So to derive a formula for compound interest, like what is the total amount after compounding interest on a particular principal amount. So let us take that first principal amount P1 as P, which is actually equal to some amount. Let's say 5,000. So let this be P1 or P. So what will be the new principal amount, or what will be the amount 1 which you will get at the end of first year? So let's say rate of interest is 5%. So what is the amount 1? Amount 1 means amount you will be getting at the end of first year. So what is the amount you will be getting at the end of first year? That will be your principal amount 1 plus I1. I1 is the interest 1 which will be added for this particular P1. So what is I1? I1 is actually interest of 5% which is added to the first principal amount P1. So I1 will be P1 into R. So P1 is actually 5,000 and R1 is actually, R is actually 5%. There is no R1 because 5% interest is fixed. So interest 1 will be P1 into R plus P1. Here you can clearly see P1 is there and here also P1 is there. You can take P1 common. So P1 will, so here when you take P1 common, 1 will be remaining, plus when you take P1 common from this, R will be remaining. So amount 1 is actually P1 into 1 plus R. Here R is actually given in terms of percentage. So here you should convert this percentage to number. So here you should actually take P1 into 1 plus R by 100. So here also you can write this particular R as R by 100. Here also you can write this as R by 100 because R is given in the form of percentage. So if you want to convert percentage to the fraction, then you should divide that by 100. So 5% means it is actually 5 by 100. So that's why instead of just writing R, you should write R by 100, R by 100, R by 100. So what will be your amount 1? Amount 1 will be the principal amount P1 plus I1. So I1 is actually P1 plus P1 into R by 100. So what you can take P1 and P1 common here. So when you take P1 and P1 common, it will become 1 plus R by 100. So here when you took P1, it will 1 will be remaining. When you take P1 from here, R by 100 will be remaining. So this will be your P2 because the amount for second year will be the P2, the amount 1. So amount 1 is actually the amount which you are getting at the end of first year. So for the second year's interest, so the entire amount 1 will become P2. So this particular amount is actually now P2 and the interest on this particular P2 will be I2. So the amount which you get at the end of second year will be P2 plus I2. That means A2 is actually equal to P2 plus P2 into R by 100 because I2 is actually the interest on P2. So interest on P2 means you are actually multiplying that with rate of interest. So I2 will be the interest on P2, that is R by 100. So R is the rate of interest divided by 100 because R will be in percentage. So that's why I am dividing it by 100. So now I2 is actually equal to P2 into R by 100. Now you can take P2 common here. So when you take P2 common, it will become 1 plus R by 100. So here also P2 you have taken, so 1 will be there. When you take P2 from here, R by 100 will be there. So what is P2? P2 is actually P1 plus 1, P1 into 1 plus R by 100. So that you can actually substitute. If you take this as equation 1 and if you take this as equation 2, you can substitute equation 1 in equation 2. So what is equation 1? Equation 1 is actually A1 is equal to this particular P1 into 1 plus R by 100, which is actually equal to P2. So this particular amount 1 has become the principal amount 2, that is P2 for the second year. So A1 is the amount which you are getting at the end of first year. P2 is that new principal amount for the second year. So that is actually P1 into 1 plus R by 100. So that P2 you can actually substitute here. So P2 is P1 into 1 plus R by 100, and this particular 1 plus R by 100 is also there. So it will become 1 plus R by 100. So P1 into 1 plus R by 100 into 1 plus R by 100. So that is actually your A2. So A2 is actually equal to P1 into 1 plus R by 100 into 1 plus R by 100. So now you can easily see here 1 plus R by 100 is one term, 1 plus R by 100 is a one term. So you can take square of 1 plus R by 100. So A2 is actually equal to P1 into 1 plus R by 100 square. So this square is there only for this 1 plus R by 100, because 1 plus R by 100 is multiplied 2 times. Now by looking at this, you can clearly see A1 was actually, here you can see A1 was actually P1 into 1 plus R by 100. A2 is actually P1 into 1 plus R by 100 square. So here you can see A1 is equal to P1 into 1 plus R by 100. Similarly, A2 is actually equal to P1 into 1 plus R by 100 square. So this particular 1 plus R by 100 as square. So similarly, AN will be equal to, N is the number of years. So let's say 10 years or 20 years. So any number you can take. So as I told, you should actually derive a general formula. So for number of years, I am putting N. So at second year and first year, by looking at first year amount and second year amounts formula, we can deduce, so we can compare and get the formula for N number of years. So what will be N number of years? It will be P1 into 1 plus R by 100 power N. So here you can see when A1 was there, power of 1 plus R by 100 was 1. When A2 was there, the power of 1 plus R2 was 2. So when AN is there, power of 1 plus R by 100 will be N. So the general formula AN is equal to P1 into 1 plus R by 100 power N. So using this general formula, you can easily find out how much amount will be remained after a certain number of years. So number of years is actually N. So based on this topic, like compound interest and interest, you have a little bit of examples in your textbooks. So you can actually refer those examples and you can actually solve exercise 7.3. So now I will be teaching you how to solve exercise 7.3. So coming to the exercise 7.3, in the first question in this particular exercise 7.3, they have given in a city, population in 2003 is actually 54,000, and this 54,000 population is reached at the rate of 5% increase in that particular population. So every year there is actually 5% growth. So every year 5% population is increasing. Based on this data, they have given two more questions in this particular first question. Coming to the first question in this particular first question, they are actually asking what was the population in 2001. So here 2001 to 2003, the difference is 2 years. So you can easily see 2003 minus 2001 will be 2. That means easily you can say that, so after 2 years, after 2001, it is 2003. So here A2 will be equal to the first population 1. So now population which was there in 2001, let us take it as P1. And whatever the population is there after 2 years, let us take that as A2. So A2 is actually equal to P1 into 1 plus R by 100 power 2. We are finding what was the initial population in 2001. So here A2 is already given, that is 54,000. But here we should actually calculate P1. So A2 is actually equal to P1 into 1 plus R by 100 power 2. So this P1, let it be here itself. We will take this 1 plus R by 100 power 2 to LHS. So here it is P1 into 1 plus R by 100 power 2. So when you take that to LHS, it will become A2 divided by 1 plus R by 100 whole square is equal to P1. So what is the P1 we are getting? P1 is A2 divided by 1 plus R by 100 whole square. So what is A2? A2 is 54,000. So divided by 1 plus what is R? R is 5%, that is 5 by 100 whole square. So now you can easily calculate this. So what is 1 plus 5 by 100? So 1 plus 5 by 100 will be P1 is equal to 54,000 divided by 1 plus 5 by 100 will be 105 by 100. So you should take LCM of denominators and then only you should actually add. So square is there. So 105 divided by 100 whole square. So now you can easily solve this. So 5, it can go with 5, like 5 2s are 10, 0, 5 2s are 10, 5 1s are 5. So again this can go with 2. So 2 tens are 20, 2 tens are 20, point 1 is there. So when you take point it will become 10, 5. So 10.5 divided by 10 is there. So this 10.5 you can actually write it as 1.05 because 10.5 divided by 10 will be 1.05 to the power of 2. So 1.05 square. In the numerator 54,000 is there. So I'll write in the new slide. So P1 is actually equal to 54,000 divided by 1.05 whole square. So what is 1.05 whole square? 1.05 whole square is actually 1.05 into 1.05. So 5 5s are 25, 2 carry, 5 zeros are 0, 0 plus 2 is 2. So 5 1s are 5. So you got 525, now 0. So 0, 0, 0. Now you can multiply with 1, 5, 0, 1. So now you can add this, it will be 5, 2, 10, 1 carry, 1, 1. So here to after 2 places decimal point is there. Here also after 2 places decimal is there. So after 4 places you should actually put a decimal point. So it will be 1.1025. So 54,000 divided by 1.1025 will be your answer. So when you do 54,000 divided by 1.1025, you will actually get 48,979.59. So here 0.59 cannot be there. So approximately we can take this as 48,980 people. So in 2001, 48,980 people were there at the rate of 5%. Every year they have got increased. So in 2002 and in 2003. So in 2003 the population was reached to 54,000. So coming to the second question in this particular same first question. So in first question again based on the same data you should actually find the answer for second question. So in second question they are actually asking what would be its population in 2005. Like we are predicting how much population will be there if it increases at the rate of 5%. So now P1 will be 54,000. So there A2 was 54,000 in first question. In second question P1 will be 54,000. So let us take P1 as 54,000 after 2 years because now you should actually calculate for 2005. So for 2005 means 2005 minus 2003 will be 2. Means after 2 years, that is in 2005, what will be the population? So A2 is actually equal to P1 into 1 plus R by 100 power 2. So here A2 we don't know. So A2 will be equal to P1 is 54,000. So 54,000 into 1 plus R by 100 whole square. So what is R? R is actually 5. So A2 will be equal to 54,000 into 1 plus 5 by 100 whole power 2. So when you actually solve this 1 plus 5 by 100, we already know that it will be 1.05. So 1.05 whole square. So what is 1.05 whole square? 1.05 whole square is actually, we have already calculated here, 1.05 here we have calculated that 1.1025. So 1.1025. So when you multiply 1.1025 with 54,000, so when you do that, you will get 59,535. So in 2005, the population of that particular city will be 59,535. So coming to the second question in this particular exercise, here they have given in a laboratory, a bacteria is actually growing on a culture. Like they have actually done a bacteria culture where initially 5,06,000 bacteria was there. So initial count of bacteria was 5,06,000 and they are actually growing at the rate of 2.5% per hour. So every hour 2.5% of bacteria are increasing for this 5,000 like 5,06,000 bacteria. So what will be the total number of bacteria after 2 hours? So here you should actually calculate A2, that is actually after 2 hours will be the first initial bacteria. Let us take that as P1, 1 plus R by 100. R is actually the rate of growth of bacteria per hour, power 2. So after 2 hours it will be 5,06,000 into 1 plus 2.5 divided by 100 whole power 2. So when you calculate 2.5 by 100 plus 1 whole power 2, you will actually get 102.5 divided by 100. So when you whole square. So here we are actually getting 5,06,000 into 102.5 divided by 100 whole square. So what is 102.5 divided by 100? So 102.5 divided by 100 will be 1.025. So when you do 1.025 whole square, you will actually get 1.050625. So when you multiply this with 5,06,000, you will get how much bacteria will be there after 2 hours. Number of bacteria after 2 hours will be 5,31,616.25. So approximately you can take it as 5,31,616 bacteria are there after 2 hours. So coming to the third question in this particular exercise. So here they have given a scooter cost was 42,000. At the rate of 8%, this particular scooter's value has got reduced because every year a property's value will go on reducing. If you take house, if you take vehicles like car, scooter or anything, every year the value of that particular property will be going on reducing just because when you use that property, value of that particular property will be going on reducing because the age of that property will be increasing. So here after 1 year you should actually calculate what will be the price of that particular scooter. So 8% is the rate of depreciation of that particular scooter's value. So now we can easily calculate this. So what is 8% of 42,000? So let us actually calculate the depreciation amount. So I'll take it as DA. So depreciation amount will be 8% of 42 by 100. So 8% of 42 by 100 will be 8 by 100. So 42,000 into 8 by 100 will be 0, 0 cancels. So 8 zeros are 0, 8 twos are 16, 1 carry, 8 fours are 32. 32 plus 1, 33. So the depreciation amount after 2 years will be, after 1 year will be 3,360. That means the value of scooter. So value of scooter after 1 year. So value of scooter after 1 year will be equal to the current value which was there, that is 42,000 minus depreciation amount which is actually calculated. So what is 42,000 minus depreciation amount for 1 year? So let us take this as DA1. So that is depreciation amount for first year. So that is actually 42,000 minus, we have already calculated here, that is 3,360. So this is DA1, that is depreciation amount in first year. So 42,000 minus 3,360. So when you do this, so you will get 38,640. So the value of scooter after 1 year will be 38,640 rupees. So this 38,640 is the answer for third question in this particular exercise. So this is all there in this particular part 2 video. So like this, I have done part 1 video also for comparing quantities. So if you want to understand comparing quantities in this 8th standard mathematics subject, so you should refer both the parts. So please refer both the parts and understand comparing quantities properly. So like this, if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.